Hi, and welcome to week 4 of Teaching Introduction to Python Programming. This week's big thought of the week is, what are some effective ways to assess student understanding beyond just checking if their code works? It's important to evaluate their thought process, problem-solving strategies, and ability to explain their work. Asking students to reflect on their coding choices through written or verbal explanations helps reveal their understanding of key concepts, even if their code isn't perfect. Additionally, incorporating peer reviews and debugging challenges encourages students to analyze, critique, and improve code, reinforcing deeper learning and computational thinking skills. Here are some other early assessment strategies that you can incorporate into your classroom. Exit tickets and slips at the end of a class period to check for understanding. Think, pair, share to get students to collaborate with others and share what they have come up with. 1-minute papers for students to prove understanding of a concept. Peer teaching or explanation to have students explain concepts to each other. Self-assessments to allow students to reflect on what they should have learned and if they feel they have reached that goal. Learning logs or journals so students can reflect on their learning and identify areas of strength and weakness. And online quizzes or polls that give instant feedback and can be used for quick checks of understanding. Next up, we'll talk about the computer science content that your students will engage in this week. Students will be able to print text in Python, define Python variables and types, incorporate user input into their programs, convert between variable types, describe the different mathematical operators that can be used in their programs, create programs that use basic math to compute useful things, and create programs that take in user input, do simple computations with the input, and produce useful output. Here are some engagement strategies you can incorporate this week. For direct instruction and guided exploration, try a mini lecture and live coding demo, do a think, pair, share, a guided code walkthrough, or a checkpoint quiz. For hands-on practice and inquiry-based learning, try student-driven discovery. Add a pair programming challenge, or have students experiment in the CodeHS sandbox. For concept reinforcement with visual aids and scaffolded problem solving, try having students take notes on an interactive document, including examples. Try a whiteboarding activity, an error debugging race, or a CodeHS lesson walkthrough and small group support. For project-based learning and real-world applications, try a project-based challenge, a peer code review, or a teacher feedback session. For assessment, reflection, and gamification, try code challenge stations, student demos, a Kahoot or quizzes game, or a reflection journal or exit ticket. Let's take a look at this week's pedagogical practice. This week, we're looking at using the sandbox for student collaboration. When you use the CodeHS sandbox, students can collaborate together at the same time on the same program. I will show you more about using the sandbox for collaboration later in this video. Some other ways to use the sandbox are to alter the start of your class. Maybe start with a collaborative debug. You can also try a fork and fix in 5. Where students will each fork the program that you share with them in the sandbox and work independently to find the solution. There are also code relays. Teams of students work together in a relay-style coding challenge where each member contributes for a set amount of time before passing control to the next teammate. The goal is to complete the challenge as quickly and accurately as possible. The first team to successfully finish, or the most complete or functional project within the time limit, wins a prize. Let's jump into the lessons for the week. In Lesson 3.1, students will learn how to make the most basic Python program, one that displays text on the screen. Students will learn how to print in Python using the print statement. They will also learn how to use quotations, apostrophes, and strings. After exploring the lesson plan, problem guides, and handouts, take a minute to reflect on the resources provided in the 3.1 free response activity. Here are some things I found while going through the lesson plan. 3.1.6 Fix This Problem does have an Explain This to Me video that you should check out. I also recommend using the Printing in Python Examples Exploration handout. Challenge your students to complete the modification for advanced students. Add an exit ticket. Have students write the commands that will print the following output. In Lesson 3.2, students will be reintroduced to the concept of variables, which store information in a program to be used later. Students will also learn about 3 different variable types: strings, integers, and floating point numbers. Make sure to take a look at all of the resources for this lesson and complete the free response activity. In the lesson plan, I recommend using the Variables and Types Examples Exploration handout. You also might consider using some kind of a graphic organizer to help your students learn the new vocabulary. This is an example of a semantic map. Let's take a deep dive and look at 3.2.7 Undefined Variables. With this exercise, I am going to show you how to use the sandbox collaboration. So I'm going to come down and find that exercise, 3.2.7, Undefined Variables. So what I'm going to do is I'm just going to click the eyeball to take a look at it. And this program has bugs in it. So if we look at the assignment, it says that it has 2 problems. One of the variables is used before it's given a value, and another of the variables isn't given a value at all. So really, to make this one work in the sandbox, I would probably add more bugs, because just having 2 bugs is going to be a pretty quick activity for the students. So what I'm going to do is I am going to copy this code, and you can do this with examples, with exercises. You can even go into the sandbox and make your own code. But what I'm going to do is I'm going to go up here to the sandbox because I just copied this, and I'm going to name my program. So I'm just going to name this 3.2.7, and I'm going to click Create Program. So now we are using Python 3, although you see you can use a lot of different things here as well, but I'm going to use Python 3. And it starts with this starter code, but I'm just going to go ahead and get rid of that. And I'm going to paste in the code that I have. And if I'm using this for collaboration, I could always come up here and I could type in a comment, find the 2 errors, or something like that. You could also put in like the names of the groups, or each group finds an error. Any of the directions that you want to give, I would put up at the top. So once you have it how you want it, you're going to come over to the left-hand side, and you're going to click where the 2 people are, and that says Collaborate. And then you're going to enable collaboration. So this is what it looks like when collaboration is activated. And so you can see right now I'm the only person in here. So I'm going to go ahead and have a student join me. In order to have students join my sandbox program, what I need to do is copy this link up here. You can give this link to your students. You can also put this link in your course if you would like. So I just gave the link to Sally's student, and she is going to click on it to get into the sandbox program. So now you can see I'm in here, I'm the teacher, and this is Sally. Sally's also in here. Let me show you what it looks like from the teacher view. Here I can see all of the students that would be in this program with me. Now you can see I have my teacher account on the left and my student account on the right. So if Sally starts typing in here to try and find the errors, you can see over on the teacher side that Sally is in pink, and I can see that Sally has just clicked right here. Sally might also highlight something, and it shows on the teacher side who did it, and it highlights it in the color that was given to that student. And you can see that Sally can see the directions up here as well. So if Sally wanted to correct something, she could come right in here and she could change it. If you decide you want to end the collaboration, you can come down here and click Disable Collaboration. And it gives you this warning message, and you can say Disable. And you see, as soon as I did that, if we look over here on the student side, it says the owner has disabled collaboration for this program, and the page is now going to reload. And there you have it. That is how you can do collaboration in the sandbox with your students. In this lesson, students revisit user input. They learn how to request user input as both strings and integers, learn where the input is stored, and learn how to convert strings and integers. Make sure to complete the lesson activity, going over the lesson plan, problem guides, and handouts. After looking through the lesson, I would recommend using the What's Your Type and the User Input Examples Exploration handouts. Try the Modification for Advanced Students activity, and I would also try the 1-minute paper early assessment strategy. This is a great way to see what students know about a particular topic. In this lesson, students will learn about using mathematical operators in their Python programs. They will work through multiple examples to get comfortable with operator precedence and using different types of operators. Make sure to go over the problem guides, handouts, planning notes, and any modifications to complete the free response activity. Some things to note are there are 2 great handouts to use. One of them is Translate to Math, and the other one is Mathematical Operators Examples Exploration. I also recommend to start with an opening discussion question and also use the Camp Counselor activity. Maybe try the peer teaching or explanation early assessment strategy with your students. Revisiting our big thought of the week, were you able to incorporate some of the early assessment strategies in your classroom this week? What did you use? What information were you able to gather? And how did you respond to that information? Make sure to complete lessons 3.1 to 3.4 as a student. And as you work, try to find places where you can incorporate some of the early assessment strategies that we've discussed. And don't forget to answer the Week 4 reflection questions. You made it through Week 4. Congratulations!